Hi, I'm Hiram and welcome back to my Python mini video tutorial series. Now, I don't have a lot left to teach you guys, so this video is going to be pretty short. In fact, I'm not even going to go into Code Sculptor this time, you're just going to see pretty old me. So, I want to talk about acceleration, and I want to talk about friction. I want to talk about why they're used in Asteroid, what the purpose of them is. I want to compare Asteroid's acceleration versus Pong, where we use simply velocity. And I want to give you a real-world explanation of what friction is, how it's used, and one way that we see friction. So let's talk about acceleration. Now, acceleration is known as the change in velocity over time. It's just a very fancy scientific mathematical way of saying faster and slower. Sorry, there's a fly here. That's all acceleration is. Acceleration is telling something to go faster or telling something to go slower. Positive acceleration is faster, negative acceleration is slower. Acceleration just changes velocity. That's all it does, is it changes velocity, while velocity changes position. See? So that's really all acceleration is. It's just a change in velocity. It's telling it, hey, go faster, go slower. Okay? So how does this work in our asteroids clone? So this works in our asteroid clone by telling our ship, when we tell it to thrust by pressing up, we tell it, hey, go faster. I want you to accelerate, right? Now, when you tell something to accelerate, you're telling it continuously go faster. You're telling it go faster, right? You're not telling it go. The reason I draw this line, this distinction, is because in Pong, we told our paddles go and stop. We didn't tell them to go faster. We just told them to go. And there's a huge difference between just saying go and saying go faster. The difference is, when you're on a car, when you're driving a car, riding a bicycle, driving a motorcycle, it doesn't matter, and you turn the throttle, you pedal, or you press the throttle, depending on what you're using, you're telling it to go faster, right? You're telling it go from stopped and then continuously go faster until you acquire a certain velocity or certain speed, right? Say you want to get to 40 miles an hour and you're in a car, you hold the throttle down until it goes up and up and up and it hits 40. Now, something that just goes is, remember when we were all little kids, or, well, not all of us, we had those little toy cars that we would ride in with the big battery, you know, the electric cars. Some are like really, really crazy now. You got like little Hummers and little Corvettes and little Barbie cars and stuff like that. When I was little, I had a little yellow Jeep. It was a little yellow Jeep, and we rode around in it had a little battery, right? And it only had one button, and it was the accelerator, right? It was the only button. It was that and the wheel. Well, that car worked very differently because that button told the car go. It didn't tell it go faster. And do you remember what happened when you would go in that little car, where the seat was, it didn't quite catch your head, it was just a little bit lower than your head, and you would go, and the first thing that would happen is you would do this. Ah! Well, the reason for that is, when you just tell it to go, it's not slowly speeding up to a certain speed. It's immediately going as fast as it possibly can. It's going to a set speed immediately. And that's giving you that jerking where it pushes you back like crazy. And then when you tell it to stop, when you let go of the go button and you tell it to stop, it doesn't slowly roll into place. It's not like pressing the brakes on a car where you're just like, la-di-da-di-da, I'm gonna stop eventually, right? It's a hard jerking motion. It's stop, oh my god, I just stopped, right? It gives you whiplash. But that is the difference between go and stop and go faster and go slower. There's a huge difference there, right? One's a hard jerking motion that gives you whiplash, and the other one's smooth and it works, it transitions well, right? So that's the really big difference there, and what plays a factor in that is acceleration. In one, you're not editing the acceleration, you're simply telling it, go this speed, and then don't go this speed. That was our Pong paddles. Remember when we pressed W or up, we told it go up 4 pixels at a time, but just keep doing that, right? And then when we let go, we said stop moving. altogether, right? It was a jerking motion, really. Whereas in asteroids, we need it to go faster. We need it to throttle. We need it to go faster and faster and faster, and then go slower and slower and slower, right? Well, we're not applying a negative acceleration. We're not actually telling it to go slower in asteroids. That's where friction comes in. Now, I've talked about how acceleration will speed you up and then get you to, and just speed you up, right? That's what acceleration does. That's what positive acceleration does, at least. It speeds you up. It makes you go faster. Friction does the opposite. If acceleration speeds you up, friction speeds you down. Friction says you're not going anywhere, right? Now, I don't want to say the textbook definition of friction. In fact, I would much rather just tell you what my definition of friction is. Friction is stuff is in your way. That is friction. Now, that doesn't sound that's not a technical definition, right? But it makes sense as far as, say, for example, have you ever heard the phrase terminal velocity? Terminal velocity is a phrase that people use for objects falling out of the sky, usually. And terminal velocity is just saying this is the maximum velocity that this object will reach from free fall, when it's free falling, because friction will not allow it to go faster. There is stuff in its way, really air, wind, all that stuff, the pressure. There is stuff in its way keeping it from going faster. That is what terminal velocity is, and that's actually what we're giving our ship in this game. We're giving it a terminal velocity. We're saying this ship cannot go faster than this speed or velocity, which is what we're using as a velocity. So it cannot go faster than this velocity, right? The velocity cannot increase past this point. Friction is the one telling it to do that. It's giving it a terminal velocity. Friction does another thing. When we thrust, we're telling it to go faster. But when we let go of the thrust, we're not telling it to go slower. We're just telling it not to go faster, right? Does that distinction make some sense to you? Let me see if I can help you out there. When we're talking about acceleration and velocity and stuff, and we say go faster, right? We're saying go faster, go faster, go faster, go faster, go faster, right? So if there's no friction, if we say go faster, go faster, go faster, and the velocity gets to 100, right? If we stop telling it to go faster, the velocity isn't going to go down. It's just not going to go up anymore, right? It's not negative, it's just the absence of positive, right? So when we stop thrusting, the acceleration goes to 0 and it stops going faster, but it keeps going the speed that it was already going, right? So how do we get that to not do that? We want it to go slower, right? We want it to slow down. That's where friction comes in again. Friction does two things in our asteroids game. It keeps our ship from going too fast, not going too fast, but it stops our ship from going faster than a certain point. And it also will slow our ship down for us, because our ship works in the opposite direction of friction, works in the opposite direction that you're trying to move, right? It's always against you. It's always against you, right? Friction is always against you. So what's it doing? When you tell it to stop going faster, when you let go of that throttle, it's going to say, okay, I need to stop going faster. And then friction is going to come in and it's going to say, hey, you need to slow down. You need to go slower right now. I'm not having any of this fast stuff. Go slower, right? So friction is going to work against the velocity, and it's going to tell it to go slower and slower and slower. And it keeps working against the velocity. Friction is a constant. It's always there. It's always working against it. That's why when your velocity gets to a certain point, it won't increase. It won't go any faster. It won't go faster because friction is telling it to go slower just as fast as acceleration is telling it to go faster, and the two just cancel each other out, and you're stuck at one same speed.